So I know we already did this slide yesterday, but just to bring us back to what we were talking about. So we know the parts of our nervous system: our brain, spinal cord, nerves, sensory receptors like our eyes, our sense of touch. We have heat receptors that are sensitive to heat and so forth. So all of those are major parts of our nervous system, but they're all made of individual nerve cells, which we call neurons. And neuron is just a nerve cell, a cell that's specially adapted to helping transmit information from one part of our body to another. Okay. So, like we said, our brain has billions, hundreds of billions of these neurons, all interconnected. Our spinal cord is made of neurons, our nerves, all these things. So we're going to look at individual neurons and sort of talk about how they work. How do they take information from one place to another? So we talked yesterday where we finished up in class, we were talking about the parts of a neuron. We have the cell body, we have the nucleus, we have the dendrites, these branches. Okay. And then we have an elongated section called the axon. And that axon extends and helps it to carry that message to another area. And then it ends in these little sort of enlargements, these little sort of bulbs called the terminal. So we'll talk now about sort of what these things do. So here we have another diagram of a neuron. And you can see all the parts here. So this is showing one individual neuron, but then you see the start of another one. If this continued, there would be another neuron here extending to the right. So the cell body is kind of like the main bulk of the cell. It contains cytoplasm, contains other organelles, it contains the nucleus. Attached to that cell body are all these little branches called dendrites. And these dendrites, think of them as kind of listening for messages from other neurons. These dendrites can pick up a signal from another neuron and sort of pass it along. And what that happens is they take a chemical signal, chemicals attached to the ends of the dendrites, and they start what we call a nerve impulse. A nerve impulse is an electrical signal. Neurons run partially on electricity. That's why an electric shock can be very dangerous to a person's nervous system, because it interferes with the normal functioning of the nervous system, of these neurons. So dendrites pick up this chemical message, turn it into electrical signal, and this electrical signal travels down the dendrite, through the cell body, and then will eventually continue all the way down the axon. Okay, so it takes the signal from one area and brings it to another area. And so the axon brings that electrical signal. And what you'll see if you follow this neuron down the axon, what you see is that it stops. This neuron doesn't physically touch the next neuron. There's a little separation between them. Okay. There's a gap. It's called the synapse. So what happens once the electrical signal gets all the way to the end of the neuron, to these terminals, what happens is it causes them to release a chemical into the gap, into the synapse. And then we're back at the start again. Then these This is another neuron. They pick up that chemical signal, turn it into electrical signal, and carry it further. And that continues from the impulse being passed from one neuron to another, until the message reaches its destination. So the synapse is this little gap between two neurons. So what part of the next neuron is this showing? This is another neuron. What part would that be? You see something?
The dendrite?
Yeah. It's a dendrite. So if I were to draw this, okay, this is, I know it doesn't continue. Okay, this is another neuron. What is this? Axon. We get to the end, and that's the terminal. So this message, if it starts here, so here I could draw this. So the message comes in. So if the message starts here, sends an electrical signal, gets to the end, to the terminal, then it releases these chemicals. They attach to this dendrite, and then that starts the message traveling again. Goes all the way down through the neuron. This is electrical signal. Gets to the end, then it releases chemicals. Gets here, electrical signal. Goes all the way down. And so this is how information passes from one neuron to another, from one part of our body to another. Now, it doesn't happen instantly. Okay? Is that what your question was? It takes a little bit of time. Might not, often we can't perceive that time, but there is a very slight delay between the time you tell, let's say, your muscle to do something and the time it actually does it. Okay? Because these steps need to happen. It happens very quickly, but it does not happen instantly. We'll talk about that one.
Oh, it's really scared.
Yeah, sort of. So again, just to give you the idea, the messages come in, get transmitted down the axon. All right, so here's an example. So we have what we call a reaction time. It takes time for us to both take in information and then process that. Okay. Did you ever go to a museum or something where they have a reaction time game and you watch the light turn green or something and you click something as soon as you see it? And again, it'll usually tell you how quickly you did it, but it's not instant because if you imagine that, you have to see the light change. So that takes time. So it's not too much time because your eyes perceive the change. The distance to get that information, your brain is pretty small. So it goes to your brain says, okay, the light just turned green. Then it says, okay, I need to press the button. It sends that message, starts this nerve impulse. It gets passed from neuron to neuron down through your spinal cord, out into nerves going down your arm, being passed on neuron to neuron to neuron until it gets to the muscles that are going to allow you to press the button. Once that message gets to the muscles, it's telling them to contract in a certain pattern for you to press the button. But it takes a little bit of time for that to happen. So some of you are probably just starting track, right? Anyone going to be doing track, modified track? No? Okay. Well, if you ever watched any track events on TV or something, you may have noticed, the runners line up. And how do they start them? In an Olympic show. Yeah, they have a gun. Not a real gun, just a loud captain sort of thing. And that's the signal that you can start running. What if you start too early? Get disqualified. Okay, in most cases, you're out of the race. So you can't start until that's definitely gone by. So this is an example. Here, if you watch this little video clip, this is Asafa Powell, one of the fastest people in the world. He's a runner, Jamaican runner. Asafa Powell is his name. He might hold the world record, I don't know, for the 100-meter sprints.
Yeah.
All right, so you hear the gun there go off, and you hear him run. So in track events, in world track events, official events, obviously you can't start till the gun goes off. But not only that, okay, if you start any faster than 0.1 seconds, it's considered a false start. So even if the gun goes off and then you start running 0.05 seconds after the gun goes off, it is still considered a false start. Why is that true? What if you start at faster than 0.1 seconds?
Because some people don't have a reaction time at the start.
Nobody has reaction time that could start that fast. So nobody could possibly hear the gun go off, send the message to their muscles in their legs to begin their sprint that fast. It's impossible. So what if you happen to do it at point less than that? What were you really doing?
Cheating.
Sort of.
Accidentally going.
You're sort of guessing, right? Like you just happened to guess when the gun was going to go off and you started your sprint earlier because nobody's reaction time is that fast. Okay? So that's what we mean by reaction time. How long does it take to take in some sensory input and respond to it? Now there are some responses that we can have that are, this is a sophopal. This is a 9.72 second 100 meter. Does not hold the world record. So this is how this works. We're not going to get into these details really, but just we have different types of neurons. Some neurons take information in, and others send information out to have some sort of response. So what's happening is, he's hearing the gun go off. Okay, he has obviously in his ears, he has sound receptors. They take the sound, turn it into a nerve impulse. It gets sent through sensory neurons into the brain. Brain process that information as, okay, there's the gun, you need to start running. Then it sends that message out to these, what we call motor neurons, that tell our muscles to move. So we have these steps along the way. Now there are some times when you have a quicker reaction, faster than all those steps. We call these reflexes. So a reflex is basically an unconscious, rapid response to some stimulus. Did you ever go to the doctor and you get your annual checkup, you sit on that table on that weird paper they put on the table, and then they tap on your patellar tendon here? You know what I'm talking about?
Yeah.
They're testing your neurological functioning. What happens when they do that? Your leg just like kicks out, but you don't like think about it. You're not like moving your leg on purpose. It just kind of happens, kind of strange. This is a built-in reflex that our bodies have. And the reason you don't feel it or you don't consciously control it is because it's a reflex. Our body has certain reflexes built in. And what happens is a nerve impulse from that tap goes through these neurons, okay, to our spinal cord. And then there's immediate response where our spinal cord connects this sensory neuron directly to a motor neuron, which causes our leg to kick out. But that signal never goes up to our brain in order for that to happen. It just goes directly through our spinal cord and back out. Another example. I'm sure you've all touched something hot, burned your hand on something by mistake. So if you, let's say the burner was on your stove, you didn't know. Or the pot was hot and you didn't know. You go to touch it, and what happens? Do you say, oh man, that's really hot, I should probably take my hands away, and then take your hand away?
No, you just do it.
It just happens, right? You just like, if you feel something hot, like your hand just snaps away almost instantly, right? It seems like there's almost no time. That's because that's a built-in reflex. that information doesn't go to your brain decides to move your hand, then the message gets sent out telling your hand to move. That would take too long. And in that time, what would be happening? You'd be damaging your hand, right? You'd be burning your skin. Okay? So it doesn't happen that way. Instead, you feel that heat sensor, it goes right to your spinal cord and right back out to your muscles, causing you to take your hand away instantly. Not instantly, there is a small delay, but a smaller delay than going up to your brain and back. Now, you also probably notice if you do that, if you burned yourself, it doesn't hurt right away, right? You may have thought, oh, I pulled off, but then all of a sudden, after a second or two, you've done some damage, and those pain receptors in your skin are now sending those messages to your brain telling you that it hurts, that you damaged your skin. Now, pain is a benefit. So, is pain useful?
No.
So pain is part of our nervous system. Okay, pain is interpreted by our brain. Okay, and why do you say it's not useful?
Because it hurts.
It does hurt. It's unpleasant. But why is it useful then? So most of you said it is useful. Zach?
Because then, like, you don't damage yourself, it works. Because if you don't feel it, then you're just going to keep hurting yourself.
Yes, pain is a signal. And pain is an adaptation, a useful adaptation to prevent us from damaging and hurting our body, right? If you push your fingers a certain way, eventually it starts to hurt, and that prevents you from breaking your own finger, right? Dislocating a joint. If you, for example, burning yourself, if we had no pain receptors and that didn't hurt, we might leave our hand on the burner and do serious damage to our body. I think we have a video we'll see another day. We got a whole bunch of videos about like neurological abnormalities. There are, in rare cases, people born without any sensation of pain. And so usually, what do you think about that?
That's sick.
Think that'd be good?
No, else than in a wheelchair.
So it's very dangerous. And people that are born with this disorder generally don't live that long, have a whole bunch of problems that come along with that because they have no sensation of pain. And we'll watch a video, I think, about what it means, like if you have a mosquito bite or something, a scratch. You know, normally if you get a mosquito bite, you might itch it for a while, starts to become red, right? And then after a little while, like, it starts to hurt. You have that sensation of pain. And that pain is telling you, okay, you're damaging your body in some way, and then you stop itching it. Well, if you never have that sensation of pain and something itches, you might just keep itching and itching until you have a huge wound in your hand because it doesn't hurt at all. People with this disorder break bones very easily. You know, if you like step strange on your ankle, it starts to hurt and you kind of catch yourself or you adjust. If you don't have that sensation of pain, you can just sprain your ankle very easily. So there's a whole bunch of things that go along with this. And we'll talk more about it once we get to that video. Hello?
And there's a signal you drown.
Okay. All right.
Does that mean you would die if you drowned?
No, because drowning is a different. You don't drown because of pain. Is not an association with drowning. It's your body's inherent, gasping for breath.
They don't feel anything like if they pinch themselves.
Yep.
Wait.
Oh, this is the
Someone
girl.
got shot, would they feel it?
No. So it's very rare. Yeah, you could still die. You would still bleed. All those same things. It just wouldn't hurt when that happens.
Wait, so it's like numb? You're like numb when you get shot?
It's not numb. You just don't
You don't
have that feeling. It's not that it's numb or you can't. It's just there's no pain receptors. We'll watch this video at some point. This is the video about it.
No, wait.
Well, you know.
Come on, please.
Please, Mr.
Well, all right. I think it's super long. Let's see.
We'll watch some of it.
All right, hold on. Actually, stop. Hold on one sec.
It's only 5 minutes.